Indicial or exponential equations. Get your books and pens ready for study.
Welcome to class. Today, we will be looking at indicial or exponential equations. These are equations with indices, are called indicial equations or exponential. The major rule with indicial or exponential equation is that when the bases are equal, the powers are also equal. That is a fundamental rule of solving indicial or exponential equation. This is what I mean. If A is raised to power m and the same A is raised to power n, since the bases are equal and this is an equation, everything has been equated to everything here. So this is an equation. So since A is the same thing as the A here, the bases are equal. When the bases are equal, then the powers are also equal. Since A is the same thing as A here, this therefore means that M, therefore, M is equals to N. So the basis is that when bases are equal, the powers are also equal. When bases are equal, the powers are also equal. And this is the principle we will be applying in the class today for this lesson. Let's go. 3 raised to power x equals to 1 over 81. Do you remember our inverse rule? That is the negative power. Looking at 81 as the denominator here, I can form a basis of 3 from 81. So I will say 3 raised to power x equals to 1 over 3 raised to power 4. We know that 3 raised to power 4 is the same thing as 81. So, using the inverse law of indices or the negative power of indices, I am going to be rewriting 1 over 3 raised to power 4 as 3 raised to power, because of the inverse, I will have minus 4. So that I have 3 raised to power x is equal to 3 raised to power minus 4. Having that, then the bases are equal. The bases on both sides are equal. And remember the rule, when the bases are equal, the powers are also equal. So, therefore, x equals to minus 4. The x that is sought after is minus 4. That is the first example we are looking at today. A second example is 1 over 2, everything raised to power x is equals to 8. We will be applying the inverse rule or the rule of negative power. So this 1 over 2. So because of the inverse, I will say I have 2, the inverse, that is negative power. Let me leave it like this for your understanding. So what I have in that bracket is 2 raised to power minus 1. Everything raised to power x is equals to, I can get a base of 2 from 8 as well. That is 2 raised to power 3. Do you remember the rule of power? Here, when a power is raised to another power, the rule says that we should just multiply the powers. So, minus 1 times x will give me minus x. So, I have 2 raised to power minus x equals to 2 raised to power 3. Now that the bases are equal, we can equate the powers such that I have minus minus x is equal to 3. But we desire to have x, not minus x. So I'll multiply both sides by minus 1. Minus 1 multiplied by 3. We are multiplying both sides by minus 1 because we intend to cancel out the minus with the x. Minus times minus is plus. 1 times x is x equals to minus times plus is minus. 1 times 3 is 3. So our x is minus 3. X equals to minus 3. We have 10 raised power x equals to 1 over 100,000. 100,000 can be written as powers of 10. We can get a base, 10 as a base from 100,000. So I will rewrite like this. This is 10 raised to power 5. Then we make use of the inverse rule, the rule of negative power for this, such that we have 10 raised to power x is equals to 10 raised to power, because of the inverse, minus 5. Now the bases are the same. The bases are equal. We are going to equate the powers, which means x equals to minus 5. X is equals to minus 5. X. 4 raised to power x plus 3 equals to 16 raised to power 2x. 16 can be written as powers of 4. So we do that. This is 4 raised to power x plus 3 equals to 4 raised to power 2, that is 16. This is our 16. Then this 16 raised to power 2x. Now we have power of power here. When we have a power raised to another power, we simply multiply the power. So we have 4 raised to power x plus 3 equals to 4 raised to power 2 times 2x, which is 4x. Now the bases are equal. We can equate the power. So equating the power, we have x plus 3 equals to 4x. Let us collect like terms. All the terms that have x, let us bring them together. So I'm taking this x over to this other side. So on my left-hand side, I am left with 3 equals to 4x. Then this plus x coming over equals to becomes minus x. 3 equals to 4x minus x. That gives 3x. The coefficient of x here is 3. So we use 3 to divide both sides. We divide both sides by 3. So I have 3 divided by 3 equals to 3x divided by 3. 3 divides 3 1. 3 divides 3 1. So I have 1 is equals to x, which is the same thing as x equals to 1. So the x that is sought after is equals to 1. We have 2 raised to power x equals to 0.125. We need to form 0.125 as powers of 2. So let's go gradually. Let me quickly take you back to the conversion of decimals to regular fraction. We have to convert 0.1 such that it will have a numerator and a denominator. Let's go. From your left-hand side, you write from the first non-zero digit. The first non-zero digit is 1. So I write my 125 divided by, you count the number of decimal places you have. 1, 2, 3. That is 10 raised to power 3, which is 1,000. So I have 125 divided by 1,000. Let's seek to reduce this to the lowest term. 125 in 125 is 1. And in 1000, I can get 125 8 times. So 125 over 1000 equals to 1 over 8. That means I have 2 raised to power x equals to 1 over 8. Now it is becoming clearer. I can write it as powers of 2. So I have 2 raised to power x equals to 1 over 2 raised to power 3. 8 is 2 raised to power 3. Using the inverse law of indices, we can write this. So I have 2 raised to power x equals to 2 raised to power, because of the inverse, 1 over, I have negative power of 3. Now the bases are equal, we can equate the powers. X equals to minus 3. X equals to minus 3. Our sixth example, 25 raised to power 5x is equal to 625. 625 can be written as powers of 25 because 25 times 25 is 625. So we write 25 raised to power 5x equals to 25 raised to power 2. The bases are equal. We can equate the power straight away, such that 5x is equals to 2. 5x equals to 2. To get our x, we divide both sides by the coefficient of x, which is 5. So we have divided by 5 equals to 2 divided by 5. 5 divides 5 once, so that x is equal to 2 over 5. The x that is sought after is 2 over 5. 0.25 raised to power x plus 1 equals to 16. We have to write 0.25 as a regular fraction with numerator and denominator. So let's seek to convert this decimal fraction to a regular fraction that has numerator and denominator. We go there again. We write from the first digit that is not 0 from our left. From my left, the first digit that is not 0 is 2. So I write 2 and the 5 divided by, I will count the number of decimal places. 1, 2. I have 2 decimal places. That is divided by 10 raised to power 2. 10 raised to power 2 is 100. 1, 2. Everything raised to power x plus 1 is equal to 16. Let's divide 25 over 100 to the lowest term. 25 divides 25 once. 25 divides 100 4 times. So we have 1 over 4. Everything raised to power x plus 1 is equal to 16. I'll be using the negative power law or the inverse law to convert this to a power of 4. That is 4 raised to power minus 1 because of the inverse. 4 raised to power minus 1 raised to power x plus 1 equals to, I will write this also as a power of 4. That is 4 raised to power 2. Now we have power of power on our left hand side. Remember, power of power, when a power is raised to another power, you simply multiply the powers. That means I have 4 raised to power minus 1 times x plus 1 equals to 4 raised to power 2. The bases are equal, we will equate the powers. So on my left hand side, I have minus 1 into x plus 1 equals to 2. Solving for our x now, I'll divide both sides by minus 1. This minus 1 outside the bracket, I want to use it to divide both sides. Minus divides minus, giving me positive. So on my left hand side, I'm left with x plus 1 equals to plus divided by minus is minus, 2 divided by 1 is 2. So I have x plus 1 is equals to minus 2. Collecting like terms, I'll take this plus 1 to the other side, to my right hand side. So on my left hand side, I am left with x equals to minus 2. This plus 1 going over equals to the right hand side becomes minus 1. So I have x is equals to minus 2 minus 1. Minus 2 minus 1 is equals to minus 3. So the x that is sought after is equals to minus 3. Example 8. We have 4 divided by 2 raised to power x equals to 64 raised to power x. It will be so wrong for you to say 4 divided by 2. No, this is not ordinary 2. This is 2 raised to power x. So the knowledge here is to represent 4 as a power of 2 and represent 64 also as a power of 2. Such that I have 2 raised to power 2 divided by 2 raised to power x equals to 64. Can be represented as 2 raised to power 6. 2 multiplying itself 6 times. Raised to power, this is our 64, raised to power x. 2 raised to power 2 divided by 2 raised to power x equals to, here I have power of power, I'll multiply the powers. 2 raised to power 6 times x, 6x. Now we are dividing and the bases are the same. So we subtract the power. On my left hand side, I'll have 2 raised to power 2 minus x equals to 2 raised to power 6x. Now the bases are equal on both sides. The bases are equal. Once the bases are equal, the powers can be equated so that we have 2x equals to 6x. Let's collect like terms. There is a term with x here and a term with x here. We can bring them together. Let me take minus x here. So on my left hand side, I am left with 2, which is equals to the right hand side, I have 6x. Then minus x coming to it becomes plus x. 2 equals to 6x plus x, that is 7x. Dividing both sides by the coefficient of x, which is 7. So I have 2 divided by 7 equals to 7x divided by 7. 7 divides 7 once. So I am left with x equals to 2 over 7. The x that is sought after is 2 over 7. Now we have graduated a little bit. Let us look at this exponential equation. 2 raised to power 2x minus 6 into 2 raised to power x plus 8 equals to 0. This is how I will go about it. In 2 raised to power 2x, I can see 2 raised to power x. So I coin it out first. This is 2 raised to power x raised to power 2. Remember, when we have power of power, we simply multiply the power. So this is x times 2, which is 2x. It's still the same thing as 2 raised to power 2x. Minus 6 into 2 raised to power x plus 8 equals to 0. Now we will be representing the 2 raised to power x by p. Let 2 raised to power x be equals to p. So anywhere I see 2 raised to power x in this equation, I'll represent it with p. So here I have p raised to power 2 minus 6p plus 8 equals to 0. Now I have a quadratic equation. By expanding minus 6p, I have minus 2p and minus 4p. So I'll group them this way. Common to the first bracket is p. So I factor out p. I will factor out p. P in p squared leaves me with p. P in minus 2p leaves me with minus 2. Common to the second bracket is minus 4. I'll factor out minus 4. Minus 4 in minus 4p leaves me with p. Minus 4 in plus 8 leaves me with minus 2 equals to 0. So, as usual, we take p minus 4 and one of these. Because this product is equal to 0, that means either of them is actually 0. Either p minus 4 is equal to 0 or p equals minus 2 equals to 0. This means side gives you positive 4 or p bringing minus 2 outside equal to positive 2. Then we have to substitute back. Remember, p is actually 2 raised to power x. So we have 2 raised to power x is equals to 4 or 2 raised to power x is equals to 2. Making 4 as powers of 2. We have 2 raised to power x is equals to 2 raised to power 2 or 2 raised to power x is equals to 2 raised to power 1. Remember, when the bases are equal, we can equate the powers. Now we have 2 here and here. So we can equate the power. That means x is equals to 2 or x is equals to 1. So this is the x that is desired. You can work it backward and find out that it is actually correct. 2 raised to power x plus 4 raised to power x equals to 72. We will make 4 a power of 2. So I will write 2 raised to power x plus 2 raised to power 2. That is my 4 raised to power x. 72. This is 2 raised to power x plus 2 raised to power x raised to power 2. I hope you know that this can be written as 2 times x, which is 2x. And this can also be written as 2 times x, which is still 2x. So bringing the x before the 2 does not change anything. I want to bring my 71 plus 72 cross over the equals to, it becomes minus 72. Then it will be equals to 0. There is nothing on my right hand side except 0. So I want to let P be equals to 2 raised to power x. So anywhere I find 2 raised to power x, I will represent it with P. So that I have P plus P raised to power 2. The entire 2 raised to power x is P. Then it's raised to power 2 minus 72 equals to 0. I will rearrange this my quadratic equation as P squared plus P minus 72. P squared plus P minus 72 equals to 0. I know that 8 times 9 will give me minus 72. So to expand my plus P, I will use minus 8P plus 9P minus 72 equals to 0. Like I said earlier on, make sure you revisit the lesson on factorization of quadratic equation. So I have expanded my plus P as minus 8P plus 9P. Grouping it like this, common to the first bracket is P. P in P squared leaves me with P. P in minus 8P leaves me with minus 8. Common to the second bracket is 9 plus 9. So I factor plus 9 out. Plus 9 in plus 9P leaves me with P. Plus 9 in minus 72, that is minus 72 divided by plus 9, leaves me with minus 8, which is equals to 0. So I have P plus 9 into P minus 8 into P minus 8 equals to 0. Use minus 8P plus 9P minus 72 equals to 0. Like I said earlier on, make sure you revisit the lesson on factorization of quadratic equation. So I have expanded my plus P as minus 8P plus 9P. Grouping it like this, common to the first bracket is P. P in P squared leaves me with P. P in minus 8P leaves me with minus 8. Common to the second bracket is 9 plus 9. So I factor plus 9 out. Plus 9 in plus 9P leaves me with P. Plus 9 in minus 72, that is minus 72 divided by plus 9, leaves me with minus 8, which is equals to 0. So I have P plus 9 into P minus 8 into P minus 8 equals to 0. That means either of them is equals to 0 or both of them is equals to 0. That is P plus 9 equals to 0 or P minus 8 is equals to 0. Plus 9 going outside becomes P equals to minus 9 or P equals to minus 8 going outside becomes plus 8. Remember that P is actually 2 raised to power x. So we have to take it back to that. So this is 2 raised to power x equals to minus 9 or 2 raised to power x is equals to 8. One way we can make minus 9 as a power of 2. So we terminate this here. That is the last stage that we get to. We can't get minus 9 as a power of 2. So on the other side, we have 2 raised power x is equals to 8. We can make it as powers of 2. That is 2 raised power x is equals to 2 raised power 3, which is 8. Now the bases are equal. We will equate the power. Therefore, x is equals to 3. Let us work it backward and see if the x is actually 3. Let's go. Plus 4 raised power x equals to 72. So if x is 3, that is 2 raised power 3 plus 4 raised power 3 equals to 72. 2 raised power 3, that is 2 multiplying itself in 3 places. 2 times 2 times 2, 8. Plus 4 raised power 3 is 4 multiplying itself in 3 places, which is 4 times 4 times 4, which is 64 equals to 72. 8 plus 64 is actually 72, which makes our x, the x that is sought after is 3. Thank you for watching. See you in the next class.
Remember to like and comment. Please subscribe to and click the notification buttons.